Okay, here it goes. I better start. All right. So, Passive House Northwest and NK Architects see an opportunity for the built environment to transition from being part of the climate problem to being part of the climate solution. And that's what the 20 by 2020 Building Catalyst is about. So it's calling for buildings that are 20 EUI or lower, that are 20,000 square feet or larger. Now 20 EUI is not a lot, so 20 kilobTUs per square foot per year. The typical office building is 92, Seattle Energy Code 51, the Bullitt Center is down to 10. So actually 20 EUI is fairly easy to accomplish through Passive House, and it also creates buildings that are in net zero energy territory. The context for all this, of course, is the climate crisis and our collective effort to address that crisis. And so here we see the greenhouse gas reduction goals for 2050, Seattle, King County, and globally. And across the economy, whether you're talking about transportation or industry or buildings, we need to see downward curves in greenhouse gas emissions like the blue curve. And if we wait and we peak later, it makes our job a lot harder. And so we have to have much steeper curves for our greenhouse gas emission reductions. Now, we've made a lot of progress in the built environment. We are becoming more energy efficient over time, but that's being wiped out right now by the growth in the built environment. We're adding billions of square feet to our built environment every decade. So the curve is going up, not down right now in US building energy use. Who are the culprits here for greenhouse gas emissions in King County? So transportation is the biggest, and buildings are number 2. Now actually these are really closely intertwined. So if we are successful at addressing greenhouse gas emissions in our buildings through energy efficiency, we can actually help address greenhouse gas emissions in transportation. And that's because as we move from gas-powered transportation to electrified transport, we're going to be adding a ton of demand on the grid. And so the question is, how do we meet that demand? Now, certainly part of the way that we'll meet that demand is through adding renewable energy. So Montana wind in this region will be a really important part of the solution. But that doesn't get us all the way there. So the key question is, how do we make up the rest of this demand? And the answer to that will determine how successful we are as a region in meeting our climate action goals. So do we add a bunch of dirty energy to our grid? Or do we instead harness the megawatts from energy efficiency in our buildings to meet that demand, right? And with this rubric, Passive House can actually power our transportation. So Passive House is this great way to reduce overall energy use in buildings by as much as 75%. And it does that by changing a few building systems, targeting a meaningful energy target, and then employing techniques in design and construction that have been used and field tested tens of thousands of times around the world with successful Passive House projects. One example of one of these projects is close to home here, and that's the Orchards Adoranco project west of Portland. Built by Walsh Construction, designed by Ankrum Moyson, 56 units of affordable housing, Passive House. It's an awesome project. Now Walsh says that the construction premium for this first building of 56 units is about 11%. So not huge, but nothing to sneeze at. However, they took the lessons learned from phase 1, applied them to building 2, which is right next door, same size, also Passive House, just completed, and they brought the premium down to 5%. So that's over a 50% reduction in that premium. And Mike Stephan at Walsh is convinced that if he were to do a building 3 next door, that he could get that number down to 2 to 3%. So what we're seeing that's the delta, that's the learning curve. It's a steep learning curve, but it's fast. And so this is the opportunity to design an incentive to deal with that delta there. So if you think of this as a chemical reaction, we have all the components in place, and the chemical reaction is going, it's just not fast enough. So when we create more ultra-efficient buildings, we learn to design and build them better, which means that construction cost falls, the supply chain responds, components get cheaper, the overall cost of buildings becomes cheaper, demand then rises, and we can build more. That's great, but it's not fast enough given the urgency that the climate crisis demands. And that's why we feel like we need this building catalyst, the 20 by 2020 catalyst. So what we're calling for in Seattle, King County, and other jurisdictions in King County is a $10 per square foot award program for 20,000 square foot buildings or larger that meet 20 EUI or better. And we want to ramp up to 20 projects awarded in 2020. And the incentive actually could be flexible. We need a catalyst, but we are modeling this after a very successful model, and that is the Brussels Exemplary Buildings Program. And so in Brussels, they used a similar incentive, $100 per square meter, almost the same as $10 per square foot. That catalyzed, or that funded 117 buildings, which resulted in the uptake of 3,000, or the building of 3,000 passive houses in Brussels, and now it's COTE there. So you can see that the curve is going down for emissions and consumption. That's what we need to see everywhere. This is while jobs and population are on the increase. Now, passive house is not just about energy. It's also about equity. So it's about reducing energy poverty and providing equitable access to fresh indoor air and to thermal comfort. And this is a good example. This is a transitional housing project in Pennsylvania, funded by an agency that prioritizes passive house. The light gray is the original building energy use. The passive house retrofit decreased energy use by 68% while providing comfort and indoor air quality. 75% better than CBEC's at baseline at a tiny cost premium. So what we have is we have the means through passive house to transform the energy performance of our buildings. We have a small learning curve we need to get over, and we've got a model for a catalyst that can make that happen. Thank you.